Imagine you have a black box in red, like Starla says, is really helpful to visualize in that way. So you have a box. You don't know, well, really right now we don't care about what is inside this box. And we have two operators, A and B. We are gonna relate these two operators in some way, and we're gonna have a result. Also, we're gonna have flags, indicators that tell me information about our result. We can directly see our result and interpret that result, take our conclusions, or this box tell us. So this box could be an arithmetic logic unit, for example, an LU. That symbol is a V. But as I said at the beginning, we are not caring about what is this box or what is inside. The point is we are going to have flags. That flags could be 0 telling me if the quantity is 0, or parity if the number of zeros is odd or even, a meter carry or a carrier, or an overflow, which is the topic of this video. Overflow is a really important flag. It's telling me a warning. It's telling me this result is not literally, how are you relating these two operators. You need to interpret it. And I'm gonna give you the result in two parts. Or well, just in one and you need to interpret the other. Okay, so let's stop talking about in general and put some examples. Overflow happens when my hardware is not able to show my result. So, as I said, it's telling me in parts. For example, when my result is a negative number. Negative numbers can be expressed in two ways. One as magnitude signs and complement. In both representations, 1 means a negative and 0 a positive. Subtraction is not as easy as adding. So what we do is a sum of negative numbers. So if instead of A minus B, you are gonna add A to minus B. For that, we complement B. We get the complement 1 of B, which is doing the complement of all the bits of B. 0 becomes 1, 0, 1, 1 to 0. And then for complement 2, we just need to add 1. And this number represents a minus B. And now we can add A and minus B together, and 0 plus 0, 0 plus 0, 0, 0, 0, 1 plus 1, 0, and we have a carrier, which is 1, and that goes carrying up to the final, having a final carry. They represent the sign of the number, which is negative, but a 0 could be positive and negative. Anyway, we have a 0, and that makes sense. A minus B or A plus minus B is 0. Here we have no problem. But when we have a conflict of signs, our box tells us a warning. The flag turns on or off depending on the logic, telling me, be aware, this is not the real result you are searching. You need to interpret it. And that is when the numbers makes no sense. In other words, to double check it, you can convert that to decimal, binary to decimal, do the operation, see what number you are hoping, and if that number does not make sense, both things. You do it something wrong, or you have an overflow and that is telling you the sign. A is less than B, and we are subtracting A to B, we result in a negative. We end in a negative result. Let's say A is 3 and B is 5, and we are subtracting them. Recall, we are not going to subtract because it's harder to sum negative numbers. So we are going to convert B to minus B to add it to A. So with complement. So B is 5. This is the representation of 5 in binary. The complement 1 is denying all those, and then the complement 2 is just adding 1. Here we have the complement B of 2, which this represents minus B, and now we are allowed to add to A. We have A plus minus B, which is this whole number, and we end up with this one. We have no carry, where here 8 bits, the carrier is the 9. We have 0 as carrier, but we have 1 at the last bit, and that is when overflow turns on. It's telling me, hey, don't be followed by that. That is the sign. So this one is telling me is negative our result. For our interpretation, we need to complement again B. So we're complementing minus B. The complement 1 of minus B, we denied all those, and then adding 1 to complement 2. And we have a 2. We have a 2 here, but now we have positive. But remind, our first result was negative. Just let me point on something, I forget it. Here, if we traduce to decimal, we have that this subtraction is 254, which is not what we are hoping. We are hoping a minus 2. So as I said before, when our results makes no sense as what we are hoping, probably we are talking about an overflow. So we complement again, and now we have the 2 we are hoping. We call magnitude, sign, scalar, vectorial, and our final result. In summary, overflow is a flag that is warning me. It's telling me that is not the result you are hoping. It's just a sign. To get the magnitude, you need to interpretate, take the complement, and then you have your result into parts, because our hardware is not able to show us that whole result. And if you think it's a problem, it's a conflict of signs, overflow is grateful. So be aware and don't be followed about your result. See your flags.